Start. Hello.
जी अस्सलाम वालेकुम सर।
वालेकुम अस्सलाम सलमान।
जी सर।
हाँ, आवाज आ रही है?
बिल्कुल बहुत साफ आ रही है माशाल्लाह सर।
राइट। अब आते उठते लगे रहो ये वड़ा ये न का अपलोड करना नोट्स ही नकल अपलोड। सलमान 1 मिनट वेट कर ले, वो नोट्स आपको लोड करने।
ओके सर।
अरे तो स्टार्ट हो क्या करना कैलकुलस वाला नोट्स यूएसडी क्यों हो जे अपलोड करे वो कहना ए सीधा da ho तेरे जगह दे तेरे हफ्ते da ho da तेरे हफ्ते वाले एसी da folder 3 की थी folder 3 की da बराबर ठीक ठीक da सब ये स्टार्ट है क्या सी da da फॉरवर्ड का बोलो दे पारा राइट ओके अब विजिबल है ना फर्स्ट पेज पार्शियल डिफरेंशिएशन
जी जी
ओके सर।
right okay let me repeat again. Here we are defining partial derivative of the function with respect to x. We are given a function in two variables x and y, and we differentiate this function with respect to x. The definition is, this is the notation, partial derivative of f with respect to partial derivative x at the point x naught y naught. This is the notation for partial differentiation of f with respect to variable x. And by definition, it is the limit h approaches 0, f of x naught plus h y naught minus f of x naught y naught divided by h. If this limit on the right hand side exists, then this is called the partial derivative of f with respect to x. Similarly, partial derivative of the function f with respect to y is defined as, this is the notation, del f divided by del y at the point x naught y naught. It is the limit x naught, f of x naught comma y naught plus h. This time we are adding this increment h to y naught minus f x naught y naught divided by h. If this limit on the right hand side exists, then this limit is called partial derivative of the function f with respect to y. And the process of finding partial derivative of the function with respect to x or y or z and so on This process is called partial differentiation. The process is called partial differentiation, and these two are the definitions. Partial derivative of the function with respect to x and partial derivative of the function with respect to y. Some notations, we use different notation for the partial differentiation. This partial derivative of f with respect to x is denoted by f of x or del f or del x or this fx without writing this x and y. So these are different notation for the partial differentiation of the function. Similarly, for partial differentiation of y, we use this notation f of y. F subscript y, xy, or del f divided by del y, or simply fy. You can use any of these notation for the partial differentiation. Right. Important thing which one should note, when you try to find the partial derivative of the function with respect to x, and you are given function, for example, in two variables, x and y, right? And you are trying to find its partial derivative with respect to x, keeping the other variable as constant, right? We don't differentiate, we don't consider this y as a variable, but in partial differentiation, we keep this as constant. And if we want to differentiate the function with respect to y, we keep x as constant. This is important thing to be noted. And you are familiar with the rules for differentiation. Those rules also equally apply in for partial differentiation. That is the sum rule, addition, difference rule, product rule, quotient rule, and power rule. These rules are also true for partial differentiation, which we shall use in these examples. Now we have this first example to clear the concept. We are given a function f of x, y, which is equal to x square. This is first example. On the next page, sorry. Yeah, this is the first example. Here the function is x square plus 3xy plus y minus 1. This is given. Function in two variables. And we are trying to find this partial differentiation with respect to x and y at the point 4 and minus 5. Write the function f of x, y. Now to find del f or del x, that is partial derivative of the function with respect to x, treat y as a constant and differentiate the function with respect to x. Now del f or del x, this can be written as applying this del and instead of function f, write the expression with respect to x. Now apply sum rule. This first differentiation this of x square, then differentiate 3xy plus differentiate y with respect to x, and plus differentiate this minus 1 with respect to x. So we apply this partial differentiation on each term. Del x square divided by del x plus del 3xy divided by del x plus del y or del x minus del 1 over del x. We use the power rule. You know that derivative of x square is equal to 2 times x. We apply the same rule. Here you have x square and we are differentiating this with respect to x. So you get 2x plus, as I said, in the next term we have 3xy. We shall differentiate this term with respect to x, keeping y as constant. So here we have two constants. One is 3 and the other is y. So taking this 3y outside and then differentiate x with respect to x. And then this del y or del x, keeping y as constant, and you know that derivative of constant is 0, and the last term is 1, which is also a constant, so it's 0. So you are left with 2x plus 3y into derivative of x with respect to x, which is 1. You get the answer 2x plus 3y. So the value, now we find the value of the function at the given point 4 minus 5. The value of del f or del x at the point 4 comma minus 5 is written as del f divided by del x, this vertical line, and down this 4 comma minus 5, which is the given point. Right there on the other side, your del f is 2x plus 3y, vertical line, and this point. Here 4 is your x, and minus 5 is your y. So putting the value of x and y in the expression, you get 2 times 4, because x is 4, and plus this minus 5, because your y is minus 5, and this gives you minus 7. So the value of the function, partial derivative of the function with respect to x at the given point is, in this case, equal to minus 7. Now we find partial derivative of y with respect to partial derivative of the function with respect to y, and in this case we shall keep x as a constant, right? So applying this del f del or del y on both sides, from the right hand side you have this first term is x, which is a constant, so its derivative with respect to y will be 0, plus 3x. Consider 3x as constant and differentiate with y with respect to y, which is 1. You are left with 3x plus derivative of y with respect to partial derivative of y with respect to y is equal to 1, and minus partial derivative of 1 with respect to y. 1 is constant, which is 0. So in this case you get 3x plus 1. And then the partial derivative of the function with respect to y at the point 4 minus 5, putting the values x equal to 4 and y is equal to minus 5 in the right hand side expression, which is 3x plus 1, you get 13 as answer. So you have this partial derivative of f with respect to x at the given point is minus 7, and partial derivative of the function with respect to y at the given point is 13. This is the answer of our solution of this example. We try another example. Right, this is example 2. Find partial derivative of the function with respect to y if f of xy is equal to y sine xy. Now here this is the product of two functions, y into sine xy. Solution, we are given that f of x is equal to y times sine xy. Applying partial differentiation, with respect to y on both sides. On the left, you have del f or del y. On the right, del, instead of function, you have its value divided by del f. Product rule. First function into derivative of the second function plus second function derivative of the first function. This is your product rule. Applying this rule, you get y times del over del y sine xy, which is your second function, plus second function product of derivative of the first function, which is del y over del y. And this gives you y times derivative of this cos sine is cos xy, and then derivative of the term inside the bracket, that is xy, plus sine xy derivative of y with respect to y is equal to 1. In the margin, you see that derivative of sine y with respect to y is cos y. Now you are left with y cos xy, and keep this keeping x as constant, x times derivative of y, which is equal to x plus sine xy, and you are left with, it's a simple example. This is just to tell you how do we apply the differentiation rules in partial differentiation. There is a third example, simple example. Now in this case, you see that your function is as a rational function. You have numerator and denominator, and you have to apply quotient rule in this case because it's in quotient form. Quotient form का formula क्या है? You know that numerator denominator's time derivative of the numerator minus numerator times derivative of the denominator divided by denominator square. This is your quotient formula. So we shall apply this formula in this case because our function is in quotient form. F of xy is equal to y divided by y plus cos x. We use this notation, f of x. Instead of del f or del x, you can use this f of x. They are the same. So we are just to get familiar with this notation. This time we use f of x instead of del f or del x. Applying on the right hand side, you have del over del x into 2y divided by y plus cos x. So by quotient rule, numerator's time, denominator's time, which is y plus cos x, here down, this is your denominator. It's a square this and then derivative of the first one, numerator, which is 2y minus this numerator times derivative of the denominator. Numerator is 2y and denominator is y plus cos x. So derivative of y plus cos x with respect to x, and this down y plus cos x square. This is by quotient rule. And from this we get this y plus cos x, and 2y is a constant because we are differentiating the function with respect to x. So we are keeping y as constant, and derivative of constant is 0 minus 2y, and then derivative of y with respect to x, applying sum rule, derivative of first function plus derivative of second function. So derivative of y with respect to x is 0 because y is constant in this case. And you know that derivative of cos x is minus sine of x. And down this y plus cos x whole square. Simplifying, you get this 2y sine x divided by y plus cos whole square. So the derivative of this function with respect to y, with respect to x is this. And now derivative of the same function with respect to y. We have this fy. And on the right hand side, you have del divided by del y. Okay, let me move to the next slide. It is on the next slide. Now here fy equal to del over del y, and this function 2y divided by y plus cos x. And like in previous case, doing this step, you get at the end 2 cos x divided by y plus cos x whole square. It means applying the quotient rule and then the sum rule, you are left with at the end 2 cos x divided by y plus cos x whole square. So this is the way how to find partial derivative of a given function with respect to x or y while using the differentiation rules. Now you see sometimes we are given a function in many variables and we cannot express the expression in one variable. Such a function is called implicit function. So in the next example, we try to find partial differentiation of an implicit function. We find partial derivative of the variable z sorry, with respect to x. If we are given this equation yz minus log z equal to x plus y. Now you see you cannot express this function, cannot write this equation just in one variable. And we have to find this derivative of this function z with respect to x. So we write this z on the one hand side and the other variables on the other hand side, and then we take derivative of both sides with respect to the function, right? Hold on, please. Okay, write the expression first. Yz minus log z equal to x plus y. And differentiate both sides with respect to x. From the left hand side, you have using difference rule del yz divided by del x minus del log z divided by x. And on the right hand side, you have this using this sum rule, derivative of x with respect to x and plus derivative of y with respect to x. And this gives you on the right hand side, you keeping yz, this y as constant, you take this outside and you are left with y times del z over del x. minus, you know, the derivative of a log z with respect to x is 1 over z into derivative of z over del x. And on the left hand side, derivative of x with respect to x is equal to 1, and since y is constant, its derivative is 0. And then derivative of writing these two terms on the left hand side is y minus 1 over z and del z over del x. This right hand side can be written in this form, and from the left and right hand side you get 1, and this can be written as zy minus 1 divided whole divided by z del z over del x, and then this is equal to del z over del x dividing the other hand side by zy minus 1. So the derivative of this uh, z with respect to x is equal to z divided by zy minus 1. So by this example, we see if we are given an implicit function, we differentiate both sides with respect to the variable which we have been asked. And this fifth example, it's a simple example. It's in 3 variables, f of x, y, z, which is equal to x sine y plus 3z. And we have to differentiate this function with respect to z. Now differentiate this function with respect to z while treating the other two variables, that is x and y, as constant. अब जितने भी वेरिएबल्स होंगे उन सबको आपने कांस्टेंट रखना है, and you have to differentiate with the one which have been asked to differentiate. So del f or del z is equal to, on the left hand side, and del or del z into x sine y plus 3z, it is equal to x. Now it is again a function of two variables, x into sine of y plus 3z. So using the product rule, this can be written as x times del or del z sine y plus z, that is first term derivative of the second plus second term derivative of the first one. So you get this, and then x derivative of sine, that is cos y plus 3z, and then differentiating this term written with the sine x, which is y plus 3z. So derivative of y plus 3z plus second term, which is sine y plus 3z, into derivative of the first term, which is x, with respect to z, which is 0. And you can write this in the form as x into cos y plus 3z, and then applying sum rule, that is del y over del z, which is 0, plus 3 times del z over del z, which is 1. So this is 3, and plus from the last term you get 0, because we are multiplying sine y plus 3z with 0. And we have this 3x cos y plus 3z. So this was one example of a function in 3 variables, and we differentiated it with respect to z. You can also differentiate this function with respect to x and y as well, getting a different answer. Another example, it was left as an exercise for you, but I have given the detail. So look at the example, find derivative of the function of z with respect to x if the equation, it's an implicit equation, as a function of two variables, dependent variables x and y, and then differentiate this with respect to z. Detail is there. This was an exercise for you. So look at the details if you cannot differentiate it. This is an equation in variables x, y, and z. And it's in implicit form. You cannot isolate one variable on one side. So you have to use the technique which was used in example 4. So applying the same techniques used in example 4 to this problem and try to solve it. Right, we move to another slide. Higher partial derivatives. So far we were considering partial differentiation, first order partial derivatives. Now we consider second order partial derivatives. By second order partial derivative, we mean of a function that we differentiate the function twice with the same variable. For example, if you are asked